So we're moving into our trigonometry unit now, and this has a lot of applications in science and engineering. So if you're thinking about studying one of those fields, you'll be seeing a lot of this in your future. Let's start out just by labeling some of the sides of this triangle. So this is a right triangle, as you can see, and the angle or the side that's opposite that right angle is always the hypotenuse. So I'm just going to label this as hypotenuse. And then for the other two sides, we're thinking about those in terms of angle A. So if we look, the side that's opposite angle A is going to be line segment BC. So that is opposite of angle A. And line segment AC is adjacent to angle A. And adjacent just means that it is right next to it. So when you're labeling your triangles, start by labeling the hypotenuse, and then you can label your opposite and adjacent. And we actually use these terms to define our trig functions. So if you look at that acronym at the top, SOHCAHTOA, that's how we remember our trig functions. So that SOH, that means that the sine function, sine of angle A, is equal to the length of, or the measurement of the opposite side, divided by the measurement of the hypotenuse. So you take the length of the opposite side, the length divided by the length of the hypotenuse, and that equals the sine of angle A. So the cosine function, cosine of A, that equals, if you look in our acronym CA, we have adjacent divided by hypotenuse. And our last function that we have is the tangent function. So tangent, or just we write that as tan of angle A, that equals the opposite divided by the adjacent. So now we're going to take a look at how we would actually use some of these functions to solve for sine, cosine, or tangent. So in our first example, we have this triangle here, ABC. We want to find the exact value of sine of A and put it in simplest radical form. So we're looking for sine of A. I think that it can be really helpful if we start out just by labeling the sides of this triangle. So over here, that 14, that is the hypotenuse. I'm just going to label it as HYP. 12, that is the opposite, so I'm going to write OPP. And that square root 52 is the adjacent side, so I'm just going to label it ADJ. If we scroll up, we said that our sine function equals opposite over hypotenuse. So I'm just going to write that down again. Sine equals opposite over hypotenuse. So it looks like I actually don't need the adjacent measurement for this particular problem. So I'm going to take the opposite side of angle A. The measurement of that is 12. So I'm doing 12, and I'm dividing by the length of the hypotenuse of this triangle, which is 14. And I just need to go ahead and simplify that now. So those are each divisible by 2. So that is going to give me 6 over 7. So the sine of angle A is 6 over 7. And that's our answer for this. Our next problem, we have another triangle here, and we're looking for cosine of A this time. So let's scroll back up and see what we need for cosine of A. Cosine equals adjacent over hypotenuse. We're using this middle function here. I'm going to write that down again. Adjacent over hypotenuse. Remember that your hypotenuse is right here, and your adjacent side is the other side that's next to angle A, so right down here. So if I'm solving for the cosine of A, I have adjacent is 3, and the hypotenuse is square root of 13. Now I can't leave a square root in my denominator, so I have to do that thing we call rationalizing the denominator, which means I'm going to multiply by the square root of 13 over the square root of 13. So I'm going to fix that. So 3 times square root 13 is 3 on the outside, square root 13. And my denominator, root 13 times root 13. Remember, anytime you multiply a square root of a number by the square root of that same number, it just equals whatever you have inside. So that just equals 13. And we don't have a square root in my denominator anymore, so that is going to be the answer. All right, one last problem. We're going to do a tangent problem. So we're looking for the tangent of this triangle. And we defined the tangent function as the opposite over the adjacent. So my opposite is this 12 over here. Remember, it's the opposite of angle A. So opposite, and my adjacent is that root 52. So tangent equals opposite over adjacent. My opposite measure is 12, and my adjacent measure is square root 52. I'm going to fix that 5. All right, so I need to rationalize my denominator again here. So I'm going to multiply by root 52 over root 52. So that is going to give me 12 square root 52 divided by 52. The square root of 52 can actually be simplified, so I'm going to do a factor tree over here to the side. So 52 divided by 2 equals 26. 26 divided by 2 equals 13. I'm going to circle my prime numbers. I have a pair of 2s, so I can bring a single 2 out of my radical, and I'm going to multiply it by that 12. So I have 12 times 2, and then inside my square root, I have 13, because there wasn't a pair for that, so that stays inside. And this is all still over 52. Now I can simplify this a little more. 12 times 2 equals 24. Square root of 13 over 52. And then I just need to simplify this fraction a little bit, because 24 and 52, that they can both be reduced. So I'm going to divide each of those by 4. 24 divided by 4 is 6. 52 divided by 4 is 13. So I get 6 square root 13 all over 13. And I can't reduce those 13s because if you look in the numerator, that 13 is inside a square root sign, but in the denominator it's not. So my answer would just stay like this.